Alright, so multiplying polynomials. The last section we had was multiplying polynomials by a monomial. Okay, and if you'll remember, a monomial was that single term out there. It could be a constant, a variable, an exponent. Okay, but it was all being multiplied. Inside could have been a polynomial, which could have been a 2-term polynomial, 3-term, or longer. Okay, and we just took that monomial and multiplied by every term inside of that polynomial. So let's practice one of those, and then we'll kind of get started with our new section. So let's say we had 2x cubed, and I'm going to times it by 4x squared plus 2y plus 3xy plus 4. Okay, so we have a 4-term polynomial here multiplied by the monomial. So one thing you could have done was you could have written it out longhand and said 2x cubed times 4x squared plus 2x cubed times 2y plus 2x cubed times 3xy plus 2x cubed times 4. Now remember, as you go, this step right here will become optional. You can kind of start and skip it, okay? It's ever how you like it right now. Okay, there's nothing wrong with expanding it out. Now let's go back and multiply these. It's a monomial by a monomial, so multiply your constant. So 2 times 4 is 8. Now I have an x cubed and an x squared. These are being multiplied, so what do I do with the exponents? I add them. So that would be x to the 5th plus, what would this term end up being multiplied by? 4. Okay, 4x cubed y plus, what have I got for the next term?
X 4y.
Okay, plus, last term? Okay, now you need to go back and look and see if there's any terms that are exactly alike. This is x to the 5th. I have no more x to the 5th powers. X cubed y, I have no more x cubed y's. Here I have x4y, I have no more x4y's, and I have x to the 3rd. Is this in standard form? No. What would make it in standard form? Okay, very good. Remember, that needs to be in decreasing or descending order. Now, be careful, because on the SOL test, they may actually trick you and say put this in ascending order by degree of polynomial, and if that means ascending, that means increasing. So I would flip it and write it the other way. Okay? What is the degree of this polynomial? 5. Okay? You add, okay, you give me the degree of each monomial. This one's 5. This one is actually 5 as well. This one is 4, and this one is 3. Okay, so 5 is my degree. All right. What is the leading coefficient? 8. Okay. Now, how do you know which one goes better in front than in the second term? This one would go better in front because you have that variable that's by himself to the 5th power, versus here you have 2 variables that add up to be 5. Okay, so your x, if you noticed, is actually descending as you go across. Okay, so that's why that one would look better. Okay, any questions on reviewing multiplying a polynomial by a monomial? Okay, tonight what you're going to do is you're going to actually multiply polynomials by other polynomials, which means it's not going to be a monomial out front anymore. It's going to start and look like this. You could even have more terms within there. Okay? So right now I just gave you 2 binomials, which means they have 2 terms each. Alright? Distributive method. What does that mean? What am I going to do if I use the distributive property? I'm going to hand out something that was in front of parentheses to everything inside. I'm going to kind of do that here. I'm going to rewrite this though. I'm going to take this first one and I'm going to break him up. So I'm going to have 2x here plus 3. So I took this and broke it up. And each of those is going to be multiplied by x plus 5. Okay? Everybody see what I did? If this was 2x minus 3, then I would have put a minus 3 here. Whatever the operation is here goes with it when you split it. Because what this is saying is this 2x using distributive is going to be, because everything's being multiplied here, okay? This 2x gets multiplied by everything here, and so I wrote it saying that to show it. And then 3 is going to be multiplied by everything here. So then I'm going to come back with a 3 and multiply by everything. Okay? So it's like if I said the boys are going to give all the girls something, like a piece of candy, a piece of gum, a pencil, okay? So then Davey would have to go around and give everybody whatever item he had, a piece of gum. And then George would have to go around and give everybody, okay? So that's kind of what we're doing, okay? The first one that's being given out is my 2x. The second thing that's given out is a 3. So I've kind of got to distribute there. Now, this is what we've been doing. So I'm going to again distribute, which means 2x times x plus 2x times 5. So again, I'm distributing again. Plus, and again, I'm going to distribute over here. So 3 times x plus 3 times 5. And now I'm going to go through and clean up and do my math. So over here I get 2x squared plus 10x plus 3x plus 15. That should be a 3, it didn't. Okay? Now, from there, what can I do? I can add the 10x and 3x. So 2x squared stays the same, and I get 13x plus 15. Why did this not change to 13x squared? Because I'm adding, so the variable does not do anything. It's like me adding, I have 10 x's over here and I have 3 more x's, so I have a total of 13 x's. The x does not change when I'm adding, only when I'm multiplying. Okay? Any question on that? Do I ever come down here and add all this and give me 30x cubed? Again, no. This is an x squared. So there's nothing else that has an x squared that I can add to that. There's no more x's. There's no more constants. Okay? So that right there is my answer.
So if you're multiplying 2x squared plus 13x,
Then I would. Yes. If you're multiplying, okay, then yes, you can. But right now I'm adding, so I cannot. I have to stop right there. Okay? Questions? Okay, I'm going to pause just for a second. I'm going to put one on the board, and I'm going to let you guys work it, and then I'll turn the recorder back on, okay? So here's the one I want you guys to do. 5y minus 2 and y plus 8. Alright, I know some of you are finishing, but let's just go ahead and get started. Lauren, what did you do for your first step? What am I going to write on the board? Minus 2 right here. Okay. Okay, everybody got that? Yeah, I did. Thank you. Alright, so Jenna, tell me now what my next step is going to look like. Okay. Okay. Everybody good with what their step is so far? That's correct. Alright, Lens, tell me what you get next.
5y squared plus 40y minus 2y minus 16.
Okay, everybody good so far? Okay, and Avery, tell me what you get last.
5 plus squared plus 38 minus 16.
Very good. Okay. New concept, not that difficult, correct? Okay. Now, let me explain. This step right here is one of those steps that you probably can start and get rid of as you practice. Okay? So as the night goes on, if you feel comfortable, you can leave that. The next one I'm going to show you, I'm going to take it out. Okay? Now, if you feel better using the expand it and doing that, do it until you get used to it, okay? But as you do more practice, you're going to be able to let go of that. So let's do this one. Let's do 3m plus 4 and m plus 5. Okay? For me to skip that, I know that this 3m has to be multiplied by both. So I'm just going to go right on down here and expand it. Because 3m gets multiplied by m, and 3m gets multiplied by 5. Thank you. Did everybody see what I did? Okay. Yeah, you're here. All right, thank you. Yes, if you don't care, get him a chair out there. All right. Then the next one is, I know 4 gets multiplied by both. All right. This is a plus 4, so that's going to be plus 4 times m plus 4 times 5. Did everybody see what I did? So I could take that one step out. Okay? I could take that one step out by saying 3m parentheses m plus 5 plus 4 parentheses m plus 5. Okay? So I kind of was able to skip that one step. Now I'm going to go back through and just finish up like we have been by multiplying each term. Then I'm going to go back through and clean up any terms that are alike. And I get that as my answer. Okay? So as you practice, you're going to get more comfortable with that step. Okay? So it's okay to leave out that one little step that we did. Alright? Anybody have a question? Alright. That's using the distributive method. Now, I'm going to kind of jump ahead. Then I'm going to come back, okay, to a binomial again. But let's say I have something like 2m plus 3, and I'm going to multiply it this time by 4m squared plus 2m minus 4. You're going to use the same method. It's still the distributive method. So 2m gets multiplied by everything. So as I expand it, it's going to be 2m times 4m squared plus 2m times 2m plus 2m times negative 4. Did everybody see where that negative 4 came from? Because of the subtract in front of the 4 forced him to be a negative 4. Now I'm going to continue on with the 3. So it's 3 times 4m squared plus 3 times 2m plus 3 times negative 4. Go through and do all multiplication. So here I have 8m cubed plus 4m squared minus 8m. Why minus 8m? Because 2 times negative 4 is negative 8, and I'm going to rewrite it as minus 8. Okay, very good. Plus 12m squared plus 6m minus 12. Go through, add terms. Now, if you want to rearrange it and write it so you see all the terms together, okay, again, this is optional right here. You don't have to do this step if you don't want to. If I want to rearrange it so I have all my variables together that are alike, I can. That's just a personal thing. If you want to do that now, go through and then add or do the math in this case. And then there's my answer. Okay, so even though your polynomial here may have more than 2 terms, I get 3 terms, I get 4 terms, I get 5 terms. What if this one over here, had 3 terms? Then what? Same thing, I'm just going to distribute 3 things. Okay? So it doesn't matter. Yes, Avery?
Do you ever think that the second one is going to be optional?
This second one, sometimes you're going to get to a point that you're going to be able to do that and go straight here. Okay? For right now, I think you probably need to write that second one just so you're not leaving it out. But yes, later in the year, you're going to be able to skip those steps. Next year, you're going to be able to skip that step. Okay? Because hopefully the more practice you get, you're going to be able to multiply 2m times 4m squared in your head and go, oh, that's 8m cubed. Okay? And so yes, as you practice and just get that skill in there more, yeah, you're going to be able to skip that. Okay? But again, if a teacher gives you partial credit, the more work you can show, the better off you're justifying your answer. Okay? Because if you told me 2 times 4 was 6, I don't know what you did. Okay? But if I see 2m times 4m squared and you gave me 6m cubed, then I know, okay, well, she knew what she was doing. It's just she accidentally multiplied wrong. And a partial teacher will give you that partial credit. Okay? All right, any questions on that one? Okay, so let's say you're saying I have something like another parentheses here, or are you saying inside here instead of add that's going to be another parentheses? Oh, right here? Okay. Finish, give me an example. Finish up. Create me something. M. Oh, cubed, I'm sorry. Okay. Four squared or 4m squared? 4 squared. Okay. Oh, this is a good one. Okay. Well, is the bracket out here too? Okay, so the bracket. So, our order of operations says I'm going to do everything inside of those parentheses first. Well, there's nothing to do here, correct? There's nothing, well, I can do something here because that's 4 squared. So I know I can come back and I can multiply. So far I'm copying just everything down until I get over here, and I'm going to have m plus 16 now. Okay? Now I need to do what's inside of this bracket. So I need to combine the terms that are alike because these are plussing the 2 terms here. So I'm going to have something like, and I can keep that in that, 2m plus m would be 3m, correct? Plus 4m cubed plus 13. True? Now I'm back to what our last problem was. So now I'm going to multiply 2m by every term, and I'm going to go back and multiply plus 3 by every term. Do I need to continue that one on? That was actually a very good one. Okay? Could you have something like that? Yeah, you sure can. Because so far there's nothing on that first problem that we haven't done. It looked intimidating. Okay? But we already knew how to do things up here first. We knew how to add those polynomials. And then once we did that, now we know how to multiply. Okay? Very good.
I have a question.
Yes. Okay, let's go back. Right here. One, two. This one and this one, or this one and this one? This one? Okay.
And how you switched 12m squared and
8m. Okay.
how did you bring minus?
Okay. What? Remember, these are like little train cars. This is the engine, and then everything that follows is their own little train car. So this plus goes with that 4m. The subtract goes with 8m. The plus goes with 12m squared. So when I move it, it's like the little hitch to the train car. It stays with that number. And so that's why this become 12m squared here plus, and this was still minus 8m because that minus is hooked with my 8. So I'm able to switch them around, okay, but I just got to keep that operation with it. Okay? Any other questions? All right. Now, looking back at this one, we used what we call the distributive method. Now, there's a shorter way that they call, and it's called FOIL. F-O-I-L. All right? And so, I want to include, actually, I probably need to go back. F-O-I-L. F, and I'm going to write it down the paper because I'm going to tell you what that stands for. Okay, so it's actually F-O-I-L, FOIL method, and it stands for something. F stands for the first terms in both polynomials. Now, typically this is done when you are multiplying a binomial by a binomial. Okay, once you get anything larger than that, there is a way you can do it, but you have to regroup where it looks like a binomial. So typically we just use distributive method, which is what we did a minute ago, okay? This is usually used on a binomial times a binomial. Alright? So the first term. So let's look at what I'm talking about down here. Let's say I have 2x plus 5 and 3x minus 2. What is the first term in this polynomial? 2x. What's the first term in this polynomial? 3x. When I do distributive property, what did I multiply 2x by first? 3x. So that's my first term, okay? Did everybody see that? It's the same thing we were doing, it's just they call it FOIL. So that's what I mean by first terms. First term and first term. O stands for outside terms in both. Alright? What do you think the outside terms are? 2x, okay? If this is all sandwiched together, let's think of this like a piece of bread, a piece of ham, a piece of cheese, and a piece of bread again. What's the outside pieces? 2x and the negative 2. So those are my outside pieces. Everybody see that? So this is an outside piece, and this is an outside piece. What do you think the I is? Inside pieces. So the inside terms. So that's going to be 5 and 3x, right? And what do you think the L stands for? If it's not the first, it's probably got to be the last. So the last terms. So you're going to multiply 5 and the negative 2. So that's what they call FOIL. First, outside, inside, last. Now, we already did that. So when I'm multiplying my first terms, we would have had 2x times 3x. Then I would have done my outside, so that would have been 2x times negative 2. Now, if I did distributive property and took 2x, would I not have already multiplied it by 3x and then the negative 2? Same thing. Okay? Then you would say, I'm going to do my inside term. So 5 times 3x, and then 5 times the negative 2, which is my 2 last. It's the same thing. So when you hear FOIL method, don't panic. It's just using the distributive method, using a polynomial. First, outside, inside, last. Okay? Alright, the last thing I want to even just bring up, and this is just so you start and hear the terminology, this is a quadratic expression. What? No. Okay, a quadratic expression, this is an expression in one variable. What do you think I mean when I say in one variable? It only has how many variables? So can it have x, y? No, because it's two variables. So it only has one variable, an expression in one variable with a degree of 2. Well, that's how mathematics is I'm looking at a quadratic expression or a quadratic equation. You're looking at your degree of 2. Okay? Now, so some things that are, I'm going to put a check mark, that are a quadratic equation would be x squared plus 2x plus 1. Why? Because I only have one variable within there. Now, yes, I have an x squared and an x, but it's all still one variable, right? It's only x's. And I have a degree of 2. Do you agree that the degree of this polynomial is 2? Things it cannot be is 2xy plus 4. Well, I have a degree of 2, but I have two variables, so that kind of throws it out. Can you have 4 squared? Where would that be? Yes or no?
No.
Why? Because I have no variables. Plus, what's the degree of 4 squared? 0. Okay, I know it has an exponent, but what is 4 squared? So now what is my degree? 0. Okay, remember constants has a 0 degree. Okay, I can have something like x squared minus 16. I'm still having one variable and I have a degree of 2. Okay, I could have y squared. That's fine. Okay, it can be any variable but only one of them. Alright. Now, can I have an x cubed? Nope, he goes in the not there because my degree is 3, right? For that one. Sorry about that.
What about x squared?
Can I have an x squared?
Yes.
Yeah, it's kind of like y squared because it's one variable and it is what now?
4x.
Is that 4x squared? Yes. Okay. I thought you were just saying 4x. What about 4x?
To make half of our test just this.
No, because I have one variable, but what's the degree? 1. So it's not quadratic. What is 4x? What kind of an expression is that? No, it starts with an L. What? Linear. That's a linear expression. 4x is a linear expression. So now we're getting into a quadratic expression which has that degree of 2. I don't know, we'll see. Alright. The other day when we took a test, you guys kind of flipped out when you saw the rectangle and I had like this shaded and this shaded and I forgot what this was. A, and then this was B, right? Okay, and I said I want you to find the area of the shaded region, correct? Okay, well, let's start. What is the area? Let's see here. I said this was a square, didn't I? I said this was B as well. I remember that now. What is the area of the big rectangle?
360.
How do you find the area of a rectangle?
Length times width.
Length times width. What is my length times width?
AB.
A times B. So, do you agree? I don't know why I put a W over here. I have no idea why there. So the area of that rectangle is A times B. I can't do anything else because I don't know what A is and I don't know what B is. But that's the area of the big one, right? What's the area of the little one? I said this was a square. But, well, I know that because this is a B and then we know this is B. So what's the area of that square? B squared. So how am I going to find out the area of only the shaded region? AB minus B squared. That is correct. Okay, because when I look here, this is the unshaded area, right? And they already told me this way was B. And I already knew the height of my rectangle all the way across is B. So I know this piece in here is B as well, right? So the area of this little piece is B squared, correct? Now, if I want only this area and this area, do you agree that that is this big area minus this small area? So therefore, that's what this is. A lot of you didn't even attempt that problem.
I can do it.
Okay, some of you attempted it and it was okay. I think
A minus Z.
I think a lot of you looked at it and go, ooh, I don't know, I'm just going to write something.
Yeah, I did.
Okay, I will tell you, you have one of these for homework tonight. But it's not going to be a monomial tonight. It's going to be a binomial. Okay, or polynomials. So instead of this being A, it might be A plus 2, and this might be B plus 3. Okay, so this is a step up from what we just did, but it's the same thing.
So
We
it's
still
A
have to
plus
solve
2.
it.
So if I had to find the area, then it would be A plus 2 times B plus 3. And I'd have to do that math. And then I would have to find the area of the smaller one. And then I would have to subtract it. So it's the same steps, you just may have more terms in there. Okay? Alright. What's the area of a triangle? Okay. Area equals 1/2 base times height. That's a triangle. There may be one that has a triangle. I can't remember by looking. Okay.
Is there formulas that we have to know this year?
No, not really. When you get to a lot of the algebra stuff, I'm going to stop that.